Hey TechnoStuds, let's get into some layer 1 basics. As we get into this, we're going to notice that it gets really granular on what needs to be defined. The purpose of this video is just to, at a high level, see what are the different components that need to be defined from a physical aspect so we can transfer this data from one location to the next. All right, in this video, we're going to start out by talking about layer 1 components, the 3 components that go into defining this layer and how we get bits from one location to the next. So those 3 components are physical, encoding, and signaling. So we're going to take a little deeper dive into this. We're still very high level, but we'll take a look at each one of those components, and specifically we will define the difference between encoding and signaling so we're clear on what those differences are. And then we're going to wrap up talking about the standards and what different standards are out there. So going back to our OSI model, let's just see how layer 1 fits into the rest of the pieces here. Layer 1 is this very bottom here, the physical layer. So this defines our media and things, how we're going to transfer those bits. We'll take a look at those different components there. But just from a data type perspective, we call that a bit, and these are the ones and zeros that are going across the line. Just a refresher though, that TCP/IP model combines those first 2 layers, the data link layer and the physical layer of the OSI model. It is just one layer, the network access layer. And the reason why is because a lot of the technologies that is out there nowadays that we use and the technologies we're talking about in this class, really there's some gray areas here, and it's not as defined as it was with the OSI model. So we're going to take a look at that also just briefly, but just realize that there's some this physical side that we're going to talk about that actually creeps up into the data link area as well. Here, let's take a little deeper dive into what I mean by that. So we see here, this is the layer 3 right here, the network layer. We have the data link layer right here, and then the physical layer right here. And so if we look at the different standards that are out here, so here are some of the standards for Ethernet, here are some of the standards for wireless LAN, and here is some of the standards for a wireless personal area network. So we see that there's different standards here, and some of these standards define some of the aspects that get up into the data link layer. So traditionally, when we saw the different protocols, it would separate that physical layer out and that data link layer out into 2 separate. But what we see with a lot of the technologies now is it's all kind of grouped up to a large degree. So we see once again, some kind of gray areas with this, and that TCP/IP model, that's why it combines this layer 1 and layer 2 into a single layer. All right, so let's talk about the 3 components that go into this layer 1. The 3 components are going to be the physical side of it, the encoding, and the signaling. So the encoding, what the encoding is there's a lot of data that's coming into that needs to be transferred across. These are the ones and zeros. So this is lining up those ones and zeros into an order that's going to be understood by the other side. We have to define what order those ones and zeros are going to go into. So that is the encoding side of this. Once we get to the encoding side, now those ones and zeros need to be changed to something physical. It needs to manifest itself into pulses of light or electronic signaling that's going across here, electrons that are being sent across a wire, or it's going into waves that are going across through the air. And so somehow we need to convert those ones and zeros into some sort of physical manifestation. So that is the signaling side of this. And then finally, the physical aspect, the actual copper lines, the connectors on each side. And so those are the 3 components, the physical side, the encoding, and the signaling. So when you stop and think about the physical side, we have NICs on both sides. So these 2 computers, let's say they're communicating, we have NIC cards on each side. Then we have some sort of media that's going between them, whether it's fiber that's going between them or copper, or perhaps we're going through the air with this. We've got that physical media that's being sent across there. And then we've got connectors on each end that is connecting these like Ethernet cable into those NIC cards. And so that's the physical side of this. And even the cable that goes across here, there's a lot of defining of what that cable looks like and how do we transfer how do we protect this data, whether there's some sort of sheathing around it. So there's a lot of aspects to the physical side that gets defined. And I'm always amazed at this because you've got these really tight tolerances. And what I mean by that is you've got these connectors on each side of these cables that's made by many different companies. And then you've got the NIC card that goes into these computers that are probably different companies that make those NIC cards. And those connectors have to fit in so perfectly with very tight tolerances. It can't be too big, otherwise it doesn't fit in, or it can't be too small, otherwise it will just fall back out. And when it fits into there, then it needs to click into place. And then somehow you need to be able to unclick it and pull it out. And so there's some really tight tolerances with this physical side, and it gets really granular on where the spacings of those conductors are going to need to be at, and where are, how do you make a connector between the two conductors. So it gets really granular on what's defined with this physical side of connecting these devices. So encoding is lining up the bits that are going to be interpreted on the other side. Obviously, both devices need to know what order those bits are going to be in so they can determine what data is within those bits. And so let me give you an example here. Here I've got a graph. When the graph is low, that's going to represent a 0. When it's high, represents a 1. So in these, I've got the middle 8 bits are going to represent the data that's being sent across. And so the data, this is going to be a 1 0 0 0 1 1 1 0 that's being sent off to the other side. And so in this example right here, I've got a starting bit of 0 that's going to flag the other side that I'm starting to communicate, and then an ending bit of 1 that says, okay, I have sent you the data now. And they could look many different ways depending on the encoding standards that are there. Maybe it's several bits that are flagged on each side, or this could look many different ways. But essentially here I've got a starting bit and an ending bit, and possibly maybe somewhere in here I want to fit some parity bits in there, so that way the other side can do a check to make sure that the information it's getting is accurate. So there's going to be some sort of encoding, the order in which the bits are put in, so the other side can understand what is being sent to it. So then signaling is to actually taking those bits and then turning it into some sort of signal that's going to be sent to the other side. So for instance, maybe we're going to go across the copper line. So a copper line, maybe we turn the copper line off and then on, off, 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 on, on. So you can see that we're sending volts or we're not sending volts. And that could be the way that we're signaling across this cable. So if it's a light, same thing. We could be off, on, off, 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 on. So that's then the light that we're turning on and off. And then there's some sort of sensor on the other side that's picking that up. Or let's say if it's going through the air, then we can somehow change the waves, and we'll talk more about waves later, but we can change waves that can be interpreted on the other side, whether it's a 0 or a 1. So that's the signaling. All right, so there can be some confusion between encoding and signaling. So let me go over the difference between there in this example of Morse code. Morse code is a standard that's out there that's for encoding. we have dots and dashes that represent some sort of letters, that represent letters and characters. And so that's Morse code, that's encoding. But it can go across many different medias, whether we're tapping it out on a wireless CB unit, or maybe it's going across some sort of copper lines, or we're using a flashlight. So it can go over different media. And so a dot and a dash is going to be represented by an on or off of the light, or it could be represented by pulses going down a wire. So that's signaling. And then encoding is that cheat sheet that you use, that's Morse code, that defines what lettering those dots and dashes represent. There are a lot of different standards out there. For this course, the ones that we're most concerned with revolve around Ethernet and wireless. But here's a list of some of the Ethernet standards that are out there. These are ones that you don't need to know all of the different nuances with these. Just know that these different standards exist. And if you're taking the Network Plus, you may need to be a little more familiar with the ones that are listed here. The ones on the left are the ones that revolve around copper lines. The ones on the right are the Ethernet standards that revolve around fiber lines. And so we can see that through the years, these have been developed. So we used to be 10 base T, used to be the older connections that were at 10 megabits per second, and then we worked up to 100 megabits per second. What I'm going to do is I'm just going to show you another resource for this, because this is constantly being developed and we're constantly coming out with new standards out there. So I'm going to bring up a browser. Hey, if you like my videos, I wouldn't mind you hitting that like button. And in this browser, I'm just going to type in Ethernet physical, if I can spell that right, physical layer. This is just Google, so I don't know that spelling matters all that much, but Ethernet physical layer, we'll click on here. It's a Wikipedia article, and then we'll be able to see some of the different physical layers that are out there. In this wiki article, as we scroll through it, we can find some of the different standards. Here, right here at the top, has a list of the contents for this specific page, and we can see all of the different speeds. And obviously, we've got faster and faster connections as we've gone along. And some of these, I mean, we have a 1.6 terabits per second. So some of these are really fast connections and are constantly being developed. But I'm just going to jump to one of the older technologies, the fast Ethernet. Some of our switches and stuff that we're going to be working with, a lot of it's going to be these fast Ethernet. So let's just take a glance at these. We can see here the first part of this section defines the twisted pair, so our Ethernet cables that we have. The second part is the fiber optics cable, so Ethernet over fiber optics. And as we look at here, it's got the standards that it has. On the end here of the fiber optics, we see ST and SC, we see LC that's in here. So what these are doing is they're defining the encoding and the signaling and the physical layer of what that looks like. So we can see how these standards define this physical layer and has once again, the encoding, signaling, and physical aspects all defined with what we see right here. So there you have it. We've talked about the layer 1 components, the layer 1 components being physical, encoding, and signaling. And then we talked about some of the standards that are out there. Once again, you don't need to know all the nuances of the different standards that are out there. Just know that these exist, and it gets pretty complex as we dig down in what is defined and how the dimensions of the physical layer of this and how the encoding and the signaling happen. So it's pretty amazing when you get down into, I really love getting down into the nuts and bolts of how this actually gets transferred across those wires.